surface integrals. Suppose that you were asked to integrate double integral over S, region S, of x minus 2y plus z times ds. And you're told that the surface S is z is equal to 4 minus x. X happens to be in between 0 and 4, and the same for y. It's in between 0 and 4. Now, the partial of z with respect to x is -1, and the partial of z with respect to y is 0. So this tells me 1 plus the partial of z with respect to x squared plus the partial of z with respect to y squared is 1 plus -1 squared is 1 plus 0 squared is 0. We get 2. So the square root of that is the square root of 2. So to do our integral, which I'll call I, so I is equal to that number we just found, the square root of 2, times the double integral. Instead of z, I'm going to put 4 minus x. Instead of z, I put 4 minus x. So I get x minus 2y plus 4 minus x, dx dy. And x goes from 0 to 4, and y goes between 0 and 4. And of course, x, take away x is 0. Square root of 2 just factors out. I want to do this integral. So all that survived here was the positive 4 minus the 2y. When you integrate that, you get 4y minus y squared from 0 to 4 dy. When you plug in 4, you get 16 minus 16. That's 0. When you plug in 0, you get 0. So it's 0 dy. The instant that's 0, the integral will equal 0. That finishes that problem. Suppose you are asked to integrate x minus 2y plus z, just like before, but we'll change the surface. Z is equal to 10. X squared plus y squared is less than or equal to 10. Actually, that's too big. How about less than or equal to 1? Well, then, the partial of z with respect to x is 0, the partial of z with respect to y is 0, because z is a constant. So 1 plus this squared plus this squared square root is just 1. So we need to multiply this integral by 1. And z is 10. So it's x minus 2y plus 10, say dx dy. If you want to do dy dx, fine. This tells me that x squared is less than or equal to 1 minus y squared. So then x is in between negative the square root of 1 minus y squared and 1 minus the square root of 1 minus y squared. I mean, this is a circle. X can be in between those. Okay, so x goes from negative the square root of 1 minus y squared all the way up to positive 1 minus y squared. And y goes from negative 1 to 1. The radius is 1. That's the radius squared, is 1. So the radius is 1. Y goes, the least y is 1, negative 1. The greatest it is positive 1. Goes from negative 1 to 1. Now, you might want to convert this to polar. We're integrating over a circle, a radius 1. The whole circle. Well, that means the r's are going from 0 to 1, and the angles are going, and theta is going from 0 to 2 pi. X is r cosine theta minus 2 times y, which is r sine theta, plus 10. And dx dy becomes r dr d theta. So you should distribute the r. And just continue from there. We've done a lot of these integrals already. Besides, as my Calc 3 teacher would always say, integration is Calc 2 material. Suppose we want to integrate. We want to compute the double integral of x, y, ds over the region S, where S happens to be the plane z equals 6 minus x minus 2y, but only the first octant. Well, z sub x, the partial of this with respect to x is negative 1. Z sub y is negative 2. You square each of these, you get 1 and 4. And you do 1 plus that. It's 1 plus this squared. 1 plus this squared is 1. Plus this squared is 4. So we get square root of 6. The square root of 6 times xy. dy dx. dy dx. So let's look at this in the xy plane. 0 is equal to 6 minus x minus 2y. If you solve for y, if you bring the y over, you get positive 2y is 6 minus x. So y equals this. And you're in the first option. That means x, y, and z are positive. Well, if we were to draw this, if x is 0, for example, 6 minus 0 is 6, divided by 2 is 3. Y equals 3. If x were 6, 6 minus 6 is 0, divided by 2 is 0, so y is 0, right here. This is the equation. Y is equal to this. Y. What does y go from? Well, down here, y is always 0, and up here, y is always 6 minus x over 2. So y goes from 0 to 6 minus x over 2. And x goes from, well, remember, x and y are positive, so we're in here. Of all those points, these points along here have the smallest x value, which is 0. And this one point over here has the largest x value, which is 6. And that's what you have to integrate. Want to evaluate the double integral of x squared plus y squared plus z squared ds, and s is z is equal to x plus 2, and x squared plus y squared less than 1. So z is equal to x plus 2. So z sub x is 1x, and z sub y is 0. So the square root of 1 plus z sub x squared plus z sub y squared, that's the square root of 2. The integrand really shouldn't change unless we're going to polar or cylindrical. Now dx, okay, so now instead of z, I should write x plus 2. Instead of z, I should write x plus 2. This is a double integral. Now we have two unknowns, at most two unknowns. Dx, dy. Now, what does x go from? X's and y's. X squared plus y squared is less than or equal to 1. That's inside the unit circle. I'll just convert this immediately. X squared plus y squared to polar, that is. X squared plus y squared is r squared plus r plus 2. Excuse me, x plus 2. R is x cosine theta plus 2 squared times r dr d theta. Dx dy becomes r dr d theta. And r goes from 0 to 1. Remember, we're given x squared plus y squared equals less than 1. Well, r always starts here, and it goes out to here. You're given a bigger angle, r starts here, it goes out to here. Over here, r is always 0. Along the circle, r is always 1. So r goes from 0 to 1, and theta goes all the way around the circle, 0 to 2 pi. And that integral is a bit easier to solve. Okay, one more problem. The same problem. We want to find the double integral of xy over z ds, and s is defined to be z is x squared plus y squared, and x squared plus y squared is less than 16. Well, z sub x is just 2x, and z sub y is 2y. So we get the square root of 1 plus this squared, 4x squared, plus this squared, which is 4y squared. But I see x squares plus y squares all over the place. I'm going to go polar. This is 1 plus 4 times x squared plus y squared. That is, it's 1 plus 4 r squared. So, since it's a function of r, it needs to stay inside. X is r cosine theta times y is r sine theta all over v, which is x squared plus y squared, better known as r squared. R times r kills off the r squared. But ds is r dr d theta. What does r go from? Well, it's a circle. It's bigger. It's outside of x squared plus y squared is equal to 4. It's outside of that. But x squared plus y squared is less than or equal to 16. So it's inside this circle. It's in between. Well, the outermost circle, r is 4, plus 16 is r squared, r is 4, and this r right here, well, that's r squared, so r must be 2. It's in between the circle, r equals 2 and r equals 4. R goes from 2 to 4. But the angle, it goes all the way around the circle. For example, it is not just this quarter here. It's not just the part in there. Then the angle would only go from 0 to pi over 4. It would only be this amount. But in our case, it isn't. It goes beyond 90 degrees. It goes beyond 180, beyond 270. It's going wild. Yep, there it is, 360. It went all the way around to 2 pi. That is the only reason I'm integrating from 0 to 2 pi. That finishes that problem and the section. Good luck with it.